Hello students, welcome to my online class. So in this session we will continue your exercise 5.1 of your class 12. Okay, next question is only find all points of discontinuity of f where f is defined by. So here we are finding where this function is discontinuous. At what point this function is discontinuous? Find model calculator. Okay. Sixth one, f of x equal to 2x plus 3 if x less than equal to 2, 2x minus 3 if x greater than 2 ಇದೆ. So individual amount is the solution. When x less than 2, f of x ಏನಿದೆ? When x less than 2 ಇದ್ದಾಗ f of x ಏನಿದೆ? 2x plus 3. Okay. When x greater than 2. So f of x value is greater than 2 is 2x minus 3. In both the cases, the f of x is a polynomial function. Already we know that the polynomial functions are continuous functions. Okay. In both the cases, f of x is polynomial. Therefore, f of x is continuous. In both the cases, when x greater than 2 and x less than 2, the function polynomial is continuous. So we have to check the continuity of this function at x equal to 2. So at x equal to 2. At x equal to 2, check what we have to check LHL, RHL and value of the function at x equal to 2. So what is LHL? LHL is totally limit of f of x as x tends to 2 minus 2 in the current function limit of 2x plus 3 as x tends to 2 minus directly substitute x ಇರೋದ್ರಲ್ಲಿ 2 ಹಾಕೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ this equals to 2 into 2 plus 3 this is 4 plus 3 7. What is RHL? This is limit of f of x as x tends to 2 plus this equals to limit of ಎಡಕ್ಕೆ ಜಾಸ್ತಿ ಇರೋದು this is 2x minus 3 as x tends to 2 plus this equals to that x ರಲ್ಲಿ 2 ಹಾಕೊಂಡ್ಬಿಡ್ರಿ 2 into 2 minus 3 4 minus 3 is 1. What about the value of the function? f of 2 ಏನಾಗುತ್ತೆ ನೋಡ್ರಿ f of 2 ಎಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ equal ಇದೆ 2x plus 3 ಇದೆ. So 2 into 2 plus 3. So ಇದನ್ನು ಚೆಕ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಎರಡು ಏನಾಗುತ್ತೆ ಇನ್ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. So ಇನ್ಈಕ್ವಲ್ ಆದ್ರೆ ಇದು ಚೆಕ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಇದು ಈಕ್ವಲ್ ಇದ್ರೆ 7 ಆಗಿದೆ. So therefore generally limit of f of x as x tends to 2 minus not equal to limit of f of x as x tends to 2 plus. So ಎರಡು ವ್ಯಾಲ್ಯೂ ಈಕ್ವಲ್ ಆಗಿಲ್ಲ. So ಎರಡು ವ್ಯಾಲ್ಯೂ ಈಕ್ವಲ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ limit does not exist. Limit does not exist. This function is discontinuous. Discontinuous at x equal to last result. Therefore, f of x is discontinuous. Therefore, f of x is discontinuous at x equal to 2. The point of discontinuity is the point of discontinuity is x equal to 2. That I want that. Next line get the point of discontinuity is x equal to 2. Okay, not on this. Similarly, the seventh one is the f of x equal to modulus of x plus 3 if x less than or equals to minus 3 then minus 2x if x less than minus 3 and 3 6x plus 2 if x greater than equal to 3 ಅಂದ್ರೆ 2 ಪಾಯಿಂಟ್ ಇದೆ minus 3 ಮತ್ತೆ plus 3 so particular 2 ಪಾಯಿಂಟ್ ಚೆಕ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ ನೋಡಿ solution when x less than minus 3 what is f of x ಏನಿದೆ f of x equal to mod x plus 3 ಇದೆ mod x ಇರೋದು ಏನಾಗುತ್ತೆ x less than minus 3 ಇದ್ರೆ minus x plus 3 ಆಗುತ್ತೆ. Already modulus function definition ಗೊತ್ತಿದೆ ನಮಗೆ. minus again the greater. So f of x is minus 2x. Minus again the minus 2x. Find x greater than 3. Greater than 3 greater than f of x. Greater than 3 there. 3 in the so less than 3 there. Minus 2x there. Find x greater than 3. So f of x is there 6x plus 2. So in all these four cases, f of x are polynomial functions, hence it is continuous. In all the above cases, f of x is polynomial function. Polynomial function. Hence, f of x is continuous. Alright? Less than minus 3 again, greater than minus 3, less than minus plus 3, greater than minus 3. All functions, all function polynomial. So all points of function is continuous. So we have to check the continuity of this function at x equal to minus 3 and x equal to 3. 3 check madbeki. Okay. At x equal to minus 3. We have to check the LHL. LHL will take point here. Limit of f of x as x tends to minus 3 minus. Okay. So minus 3 is the conveyor function. How define modulus of x plus 3 rather than minus x plus 3. So this is limit of minus x plus 3 as x tends to minus 3 minus. So x is minus 3 direct again. Minus of minus 3 plus 3. So this is minus 3 minus plus 3 plus 3 is 6. What is RHL? Limit of f of x as x tends to minus 3 plus minus 3 in the order of function different order of mode. Limit of minus 3 in the order of minus 2x there. Minus 2x as x tends to minus 3 plus. So x is direct again. Minus 3 minus 2 into minus 3. This is also what? 6. So shared value equal like what is the value of this function at x equal to minus 3? X equal to minus 3 and equal sign. So modulus of x plus 3 there. Modulus of x plus 3. This equals to modulus of minus 3 plus 3. This is also what? 6. Modulus of minus 3 and plus 3. Plus 3 plus 3. 6. Therefore, limit of f of x as x tends to minus 3 minus equal to limit of f of x as x tends to minus 3 plus that's equals to f of minus 3. More value equal to hence f of x is continuous at x equal to minus 3. So we have to check if continuity of this function at x equal to 3. At x equal to 3 check madbeki. So what is LHL? Limit of f of x as x tends to 3 minus this equals to 3 is the conveyor function and different method minus 2x there. So limit of minus 2x as x tends to 3 minus this value is direct x value 3 substitute madbodi minus 2 into 3 that is minus 6. What is RHL? Limit of f of x as x tends to 3 plus limit of 3 plus 3 plus 3 in the order of 6x plus 2 is there. 6x plus 2 as x tends to 3 plus direct x 3 accommodate 6 into 3 plus 2 this is 20. 6 into 3 18 18 plus 2 is 20. So ಇವೆರಡು unequal ಆಗಿದೆ. ಇವೆರಡು ಈಕ್ವಲ್ ಆಗಿಲ್ಲ. ನೀವು ಮತ್ತೆ ವ್ಯಾಲ್ಯೂ ಫಂಕ್ಷನ್ ಅನ್ನು ಫೈಂಡ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಹೇಳ್ಬೋದು ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ therefore limit of f of x as x tends to 3 minus not equal to limit of f of x as x tends to 3 plus. Hence f of x is discontinuous. Hence f of x is discontinuous at x equal to 3. The point of discontinuity is at x equal to 3. So this is the answer. Okay. Note. Next, 8th question. F of x equal to modulus of x divided by x if x not equals to 0. X not equal to 0 right? At a point x equal to 0 bitu. So x is the LHL hogi, RHL hogi. That function is defined by modulus of x divided by x. Okay. 0 if x equal to 0 is there. Okay, no. Solution. When x less than 0, f of x in this equals to when x less than 0, not equals to 0 means what? If 0 LHL side RHL side that function is given by modulus of x divided by x. So f of x is given by minus less than 0 is less than 0 minus x bar x and this value is minus 1. Okay. When x greater than 0, f of x is x greater than 0 modulus divided by x modulus plus x plus x divided by x that value is 1. You cancel that. Okay. So in both the cases the function is constant. In both the cases function is constant. The functions already we know that the constant functions are continuous functions. What is it? In both the cases f of x is constant. Hence f of x is continuous. But we have to check the continuity of this function at x equal to 0. So 0 point check continuous LHL, RHL and value of the function check. Next at x equal to 0 check. At x equal to 0 LHL limit of f of x as x tends to 0 minus the function minus the value direct limit of minus x divided by x direct minus 1 by so minus 1 plus x equal to x tends to 0 minus. This constant function limit substitute value minus 1 add. What is RHL value? RHL is limit of f of x tends to 0 plus. That's equals to limit of 0 plus that value is 1. So x tends to 0 plus. That's if you put the value 1 add. So what is the value of f of 0? F of 0 already defined after that. That value is 0. More LHL not equal to RHL not equal to f of 0. So this function is discontinuous at x equal to 0. The point of discontinuity is x equal to 0. Right on the result. Therefore, limit of f of x as x tends to 0 minus not equal to limit of f of x as x tends to 0 plus not equal to f of 0. Hence f of x is discontinuous. Hence f of x is discontinuous at x equal to 0. The point of discontinuity is x equal to 0. So x equal to 0 is a function discontinuous. Okay, now down. And the second one, the same with a similar solution. Check for you. When x less than 0. When x less than 0, function and define x less than 0. X divided by modulus of x is x divided by modulus of x is x less than 0 modulus of x value that is replaced by minus x. x less than 0 ಇತ್ತಂದ್ರೆ modulus x value minus x ಆಗುತ್ತೆ. So this value is minus 1. X cancel ಆಗುತ್ತೆ. That value is minus 1. When x greater than 0 ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡೋದು? So f of x equals to this minus 1. In both the cases, when x less than 0 and x greater than 0, in both the cases, f of x is constant function. So f of x is continuous. We have to check the continuity of this function at x equal to 0. 0 ಮಾಡಿ check ಮಾಡಬೇಕು ಈಗ ಅಷ್ಟೇ. In both the cases, f of x is constant function. Hence, f of x is continuous. So at x equal to 0, we have to check the LHL and RHL. LHL and RHL, left hand limit of f of x as x tends to 0 minus 0 ಗೆ ಕಡಿಮೆ ಹೋಗಿ ಡಿಫೈನ್ ಮಾಡಿದ್ದಾರೆ. ಡೈರೆಕ್ಟ್ ಇಲ್ಲಿ ನೋಡಿ. Limit of minus 1 as x tends to 0 minus. It's a constant function. Its value is minus 1 always. What is RHL? Limit of f of x as x tends to 0 plus. This equals to limit of 0 plus is there. Already define what the value is of minus 1. X tends to 0 plus. This value is also what? Minus 1. What's the value of f of 0? Already define what the x equals to again minus 1. So in these three cases, LHL, RHL and f of 0 all are equal. So write down. Therefore, limit of f of x as x tends to 0 minus equal to limit of f of x as x tends to 0 plus equal to f of 0. Hence, f of x is continuous at x equal to 0. So there is no point of discontinuity. ಯಾವ point of function discontinuous ಆಗೋದಿಲ್ಲ. So there is a result in there is no point of discontinuity. Okay. Now next question. 10th one. F of x equal to x plus 1 if x greater than equal to 1 is x square plus 1 if x less than 1. So we have to case alone on the solution. When x greater than 1 in the f of x greater than 1 f of x in the x plus 1 is there. When x less than 1 f of x equal to less than 1 again is x square plus 1 is there. So you have to function in the polynomial function. So polynomial functions are continuous functions. In both the cases, f of x is polynomial. Polynomial function. Hence, f of x is continuous for x greater than 1 and x less than 1. We have to check the continuity of this function at x equal to 1. So at x equal to 1, LHL. So limit of f of x as x tends to 1 minus meaning for different function limit 1 minus x square plus 1 as x tends to 1 minus and directly x value 1 substitute 1 square plus 1 that is 1 square value is 1 1 plus 1 is 2. What is RHL? Limit of f of x as x tends to 1 plus that goes to limit of 1 plus 1 x plus 1 so x tends to 1 plus this is x equal to 1 plus 1 is again it is 2. What is the value of this function at x equal to 1? At x equal to 1 is this is 1 plus 1. This is also 2. Okay. Therefore, limit of f of x tends to 1 minus equal to limit of f of x as x tends to 1 plus equal to f of 1. So f of x is continuous. More equal argument. Therefore, f of x is continuous at x equal to 1. Okay, not at this point. And this one, solution. Find x less than 2. F of x in there, x cube minus 3. Find x greater than 2. So f of x in there, x square plus 1. In both the cases, f of x is polynomial. F of x is polynomial. What is it? In both the cases, f of x is polynomial function. Okay. Hence, f of x is continuous. So I check the continuity of this function at x equal to 2. So at x equal to 2. So what is left hand limit? Limit of f of x as x tends to 2 minus 2 in the limit of x cube minus 3 as x tends to 2 minus directly x is 2 x is 2. So 2 cube minus 3 means 2 cube means 8 minus 3 is 5. Okay, what is our actual limit of f of x as x tends to 2 plus equal to limit of 2 means 0, clear, x square plus 1 as x tends to 2 plus this equals to direct x is 2 according 2 square plus 1, that is 2 square is 4, 4 plus 1 is 5. So what is the value of this function at x equal to f of 2 here directly x cube minus 3, x cube means 2 cube minus 3, this value is also what? 5. 8 minus 3 is 5. Therefore, limit of f of x and x tends to 2 minus equal to limit of f of x and x tends to 2 plus equal to value of this function at x equal to. So more value equal like therefore this function is continuous at x equal to 2. Hence there is no point of discontinuity. So function continuous function. Result f of x is continuous at x equal to, therefore there is no point of discontinuity. Okay. First one, f of x equal to x to the power 10 minus 1 if x less than equal to 1. X square if x greater than 1. So check one of them. Solution. Find x less than 1. So f of x in there less than 1 again. X to the power 10 minus 1 in there. Find x greater than 1. So f of x value in there x squared. So these two functions are polynomial functions. In both the cases, f of x is polynomial function. Hence f of x is continuous. Okay, so we have to check the continuity of this function at x equal to 1. What is value of LHL? Limit of f of x as x tends to 1 minus 1 in limit of x to the power 10 minus 1 as x tends to 1 minus. This value is That's 1 to the power 10 minus 1. 1 to the power 10 is equal to 1. 1 minus 1 is 0. What is RHL? Limit of f of x as x tends to 1 plus this equals to limit of 1 can just there x square. X square as x tends to 1 plus. So x is 1 equal to 1 square is 1. So that will be equal to okay, ये हम छोड़ therefore limit of f of x as x tends to 1 minus not equal to limit of f of x as x tends to 1 plus. Okay. Hence, f of x is discontinuous at x equal to 1. The point of discontinuity is the point of discontinuity is x equal to Third one is the function defined by f of x equal to x plus 5 if x less than or equal to 1, x minus 5 if x greater than 1, a continuous function. So, continuous function check. Okay, check. Solution. When x less than 1, so f of x is there. This is x plus 5. Find x greater than 1. F of x is x minus 5. So both the functions are polynomial functions. In both the cases, f of x is polynomial function, hence f of x is continuous. So we have to check this function at x equal to 1. At x equal to 1 we check x less than 1 is continuous side, greater than 1 is function continuous side. So we have to check this continuity of this function at x equal to 1. So left hand limit and limit of f of x as x tends to 1 minus this equals to limit of what is the x plus 5 and x tends to 1 minus x will 1 plus 5 is 6. 6 RHL value limit of f of x tends to 1 plus this equals to limit of 1 is the value clear x minus 5 as x tends to 1 plus this equals to 1 minus 5, this is minus 4. So now value of the function at x equal to 1 check equal. So therefore limit of f of x as x tends to 1 minus not equal to limit of f of x as x tends to 1 plus. Hence f of x is discontinuous at x equal to 1. The point of discontinuity is is